In this video, we're going to look at special products of binomials. When you square a binomial, you get a trinomial with a very specific pattern. And it's easy to show how we get this pattern by taking the product a plus b times a plus b. When we multiply this out, we get the product of the first terms, a times a is a squared. We get the product of the outer terms, a times b, and the product of the inner terms, a times b. ab plus ab is equal to 2ab, and the product of the last terms is b squared. Using this formula is not really easier than just multiplying this out the way we did here, but it's important to understand this pattern. And it's really important to understand that a plus b squared is not just a squared plus b squared. We get a middle term, 2ab, from the product of the outer terms and the inner terms, which in this case are the same. We call this a perfect square trinomial because when we factor it, we get two factors that are the same, so we can write it as a perfect square. A minus b to the second power will have a similar pattern, except that the middle term is negative, because the b will be negative in each of these, and that makes the two middle terms negative. Minus ab will be negative 2ab. And of course, negative b times negative b is still positive b squared because of the double negative. We also have a difference of squares, and we get this when we multiply two binomials of the form a plus b, a minus b. When we multiply these out, again, we get a times a is a squared for the product of the first terms. Then we get a times negative b, which is negative ab for the outer terms. Positive b times a is positive ab for the inner terms. And positive b times negative b is negative b squared for the last terms. Here the two middle terms are opposites, so they add up to 0. And that means we're just left with a squared minus b squared. This is a very important pattern, and when we factor polynomials that are a difference of perfect squares, we'll get factors that are exactly like this. Once you get familiar with this pattern, factoring a difference of squares should be very easy. You won't really have to do any trial and error for this. Let's start with an example of a perfect square trinomial. First, you need to identify that this is a perfect square trinomial. And once you notice that the first term and the last term are both perfect squares, then you just need to check that the middle term follows this pattern. So first, let's identify the a and the b in this trinomial. So I want to write the first and last terms as something to the second power. Here the first term is already in that form, y squared, and we don't really need the parentheses here, but I think it makes it easier to identify the a and the b. And you'll need the parentheses here if you have a perfect square coefficient in front of the variable. Now we can see that a is equal to y, that gives us a squared, and b is equal to 9, that gives us the b squared. Now with a equal to y and b equal to 9, we need to check if 2 times a times b is equal to 18y. And we see that 2 times a times b is 2 times y times 9, which is equal to 18y. So this is a perfect square trinomial. And because the 18y is positive, that means we'd be using this first formula. So this will factor as a plus b to the second power, which will be y plus 9 to the second power. So this is how we would factor using the formula. We first check that this is a perfect square trinomial, and then plug in the appropriate values for a and b. There's nothing wrong with using the formula to factor these, and it is important to understand this pattern. But once you see that you have a perfect square in the first term and the last term, it's just as easy to check this using our regular factoring techniques. So here in the first positions of the binomials, I'll put the factors y times y. And in the last positions, I'll put the factors 9 times 9 from the last term here in the trinomial. And now checking the product of the inner terms and the product of the outer terms, you can see that we get 9y plus 9y equals 18y. And that's the middle term that we need here. So now we're done factoring. These 9's are both positive to get a positive 18y. So we get the product of the binomials, y plus 9 times y plus 9. And when both factors are the same, we can write that as y plus 9 to the second power. You can see that both of these methods are about the same amount of work. I prefer using our regular factoring techniques, but as I said before, it's still important to understand the patterns in these formulas. Let's look at another example. Here we have another trinomial with a perfect square in the first term and a perfect square in the last term. So this could be a perfect square trinomial. Let's check that using our regular factoring. There are, of course, other factors of 4x squared and 25, but we're going to check the perfect square factors first. Notice that the 5's here have to have the same sign because the product is positive, but they will both be negative because the middle term is negative. So let's put the 2x in each of the first positions of the binomials and the negative 5 in the last positions. Now when we check, we have the product of the inner terms, negative 10x, and the product of the outer terms, also negative 10x. That gives us negative 20x, which is the middle term. So this is a perfect square trinomial because we got two equal factors. So this product can be written as 2x minus 5 to the second power. If you want to use the formula, you have to identify your a and your b in this trinomial. Here, 4x squared can be written as 2x in parentheses all to the second power. Notice that's the same thing we got here when we factored. And 25 is 5 to the second power. So we have a is equal to 2x and b is equal to 5. Now we need to check the middle term. Since this is negative 20x, we're using the formula with the negative 2ab. Negative 2ab is negative 2 times 2x times 5, and this gives us negative 4 times 5, or negative 20 times x. So this trinomial follows the pattern in the second formula with the a squared minus 2ab plus b squared. That means this will factor as a minus b to the second power, or 2x minus 5 to the second power. And again, either of these methods would be perfectly fine to factor this trinomial. Just be sure to show your work. Show how you came up with the 2x minus 5 to the second power, either by checking that the trinomial fits the formula and substituting for a and b, or by showing the steps in our regular factoring techniques. Now let's look at a difference of squares. These are easy to identify because we have a perfect square minus another perfect square. And since there's no middle term to check, we just need to identify a and b and write the two factors a plus b times a minus b. A is w and b is 8 because 8 squared is equal to 64. So that gives us the factors a plus b, or w plus 8, times a minus b, w minus 8. And it's easy to check the product of the inner and the outer terms here. Positive 8w plus negative 8w is equal to 0. So we have no middle term or no w term here. And of course, these factors are not the same, so we cannot combine them with an exponent. Let's look at one more difference of squares. Here we have 9x squared minus 49y squared. These are both perfect squares because the coefficients are perfect squares and the variables are perfect squares. So this is a difference of squares. 9x squared is 3x all raised to the second power, and 49y squared is 7y all raised to the second power. So here a is equal to 3x and b is equal to 7y. And that gives us the two factors a plus b times a minus b, 3x plus 7y times 3x minus 7y. You can check the product of the inner terms and the outer terms here. We would get a positive 21xy and a negative 21xy. So those add up to 0, and we're left with no middle term here, just the a squared and the b squared. So a difference of squares is really the easiest polynomial to factor. One important thing to note here is that this must be a difference of squares, because we need the opposite signs to get the middle term to cancel out. And the opposite signs gives us the negative or the difference on the second term. A sum of squares will not be factorable. We won't be able to factor a sum of squares into a product of binomials because the last term is positive, and that means that the factors will have to have the same signs, either both positive or both negative. And no matter which pair of factors you use, since they're going to either both be positive or both negative, that means that these terms will not cancel out. In this case, we would either get a positive 10x for our middle term or a negative 10x. So we get the x squared and the plus 25 in both of these cases, but we don't get the 0x for the middle term. In order to get that, we would have to have the difference of these squares so that we could have opposite signs. This polynomial is not factorable.